In this session, I shall prove a number of identities in trigonometry. So let me start with these three. Cosine squared theta equals plus sine squared theta is equal to 1. One plus tangent squared theta equals to secant squared theta. Cotangent squared theta plus 1 is equal to cosecant squared theta. So let me start with this. Now in order to do this, we shall start with some definitions. Let me call this 1, 2, and 3. So first, the definitions of sine and cosine. Let me call this x, y, and r. Okay, so sine theta is defined as opposite over hypotenuse. That's y over r. Cosine theta is adjacent over hypotenuse. So that is x over r. If I use Pythagoras theorem, I know that x squared plus y squared is equal to r squared. And these three relations, so those two definitions and this result, this formula, allows us to prove the first one. Okay, in order to see how to do it, notice that if you look at cosine, it's this formula here. If you look at sine, it's that formula there. Now if we have to think about actually proving a formula, it is often useful to look at the formula and see if it can give us some idea. In fact, the simplest way is to actually start by working backwards. So imagine substituting those two into here. Let me try that. Substitute into 1. Right, into this expression here. Substitute those two. This gives x over r squared plus y over r squared, okay, going into there and there, is equal to 1. This gives this. Okay, so this is what we're going to try. If we then multiply by r, right, by r squared to get rid of the denominators, and why I might want to do that is because this is beginning to look like the Pythagoras theorem. I'll get exactly the Pythagoras theorem. Okay, so you can see that now we have now found the connection between those two. It's getting a bit bright. Give me a second to adjust the camera. Okay, let's try that. Okay, right, so what I've just done is I've not actually proven or written out a proper proof yet. What I've done is I've made use of the result that I want to prove and try to work backwards to see if I can get back at the definitions or starting formulas that I want to use. Okay, so that is kind of quite clear that the formula is true, but if I want to write out a proper proof, I shouldn't start from something that I don't know yet that I want to prove. So what I can do is I can now make use of this knowledge to actually go in the reverse, starting from the definitions and the starting formula. So this is what I'll do. Okay, so now I want to try to write down the actual proof starting from definitions. I would say, right, from the Pythagoras theorem. So we quote that, x squared plus y squared, starting from something that we know to be true. Then divide by r squared, right? Because I want to turn it into this, which gives the sine and cosine. Okay, this gives x squared over r squared plus y squared over r squared equals to 1. Then we make use of the definitions of sine and cosine. So by definitions, I'll have sine squared theta plus cosine squared theta equals to 1. And that completes the proof for the first identity. Now for the next identity, we would need to start from the definitions of tangent and secant and cotangent and cosecant. So let me write those down first. Now from let's see, from the definitions, from the right-angled triangle, the tangent of theta is defined as opposite over hypotenuse. Let me write that down. Opposite is y, adjacent is x. But it turns out that there is another form of this which will make things easier afterwards, and that form is to relate tangent theta, relate y over x to sine and cosine, because you notice that both sine and cosine contain r. Now think about what happens if I divide this by this. Then r and r cancels, and I'll be left with just y over x, which is the tangent of theta. So this means that I can actually that tangent theta is actually equal to sine theta over cosine theta. So let me write this out logically. For example, I could write down the relation by saying, I could relate this to sine cosine by saying that, say if I divide both the top and bottom by r, okay, then I get y over r on top and x over r at the bottom. And we know that y over r is sine theta, x over r is cosine theta. So there, we have the relation between tangent theta and sine and cosine. So we'll make use of that. And the next thing is to write down the definition of secant theta. Secant theta is just defined as 1 over cosine theta. And then we need the definition of cotangent theta, and that's defined as 1 over tangent theta. And the next one that we need is, right, it's cosecant theta, and that is defined as 1 over sine theta. Right. Okay, so now we are ready to go. Let me start by trying to prove this. As before, it's easier to actually start from here, or to start by getting some idea from here. So let me substitute the definitions into tangent and secant, and see whether that leads us somewhere. So I start with 1, that's equation 2. I'm just going to say I start with 1 plus tangent squared theta equals to, so this is what we're going to try. Equal to secant squared theta. Now if I substitute the definitions in terms of sine and cosine, and this one, this is the same as 1 plus, let's say, sine squared theta over cosine squared theta, and that is 1 over cosine squared theta. I have fractions here, so we do what we might often do in algebra, get rid of the fractions by multiplying by all the denominators. So in this case, I would multiply by cosine squared theta on both sides. That gives cosine squared theta times 1 gives cosine squared theta, plus cosine squared theta times this cancels out the bottom and leaves sine squared theta. Cosine squared theta times 1 over cosine squared theta is 1. Now that is our familiar identity that we just proved from here. So this is what we know to be true. Okay. Now that we have found the connection, I can now write out the proof starting from this identity, which we know, and then writing it out backwards. So the actual proof looks like this. I start from an identity. Cosine squared theta plus sine squared theta equals to 1. Alright, this is the step where I want to actually write out the proof. And then I say I would divide both sides by cosine squared theta. That gives 1 plus, they cancel, plus sine squared theta over cosine squared theta equals to 1 over cosine squared theta. Right? And finally, that is tangent squared theta. This is from the definitions, and that is 1 over cosine is secant, so that's secant squared theta, and this completes our proof. And if we look at the third item that I wanted to prove, this one, we can use the same idea as before by starting from what we want to prove and substituting definitions inside. until we see something that looks like an identity that we know. Okay, so I shan't go through the steps to try that out. I'm just going to start straight with the proof this time. So right here I've proven for the second identity. So now I want to prove for the third identity. Starting from, again, from the identity cosine squared theta plus sine squared theta equals to 1. I shall divide both sides by sine squared theta this time. That gives cosine squared theta over sine squared theta. Sine squared over sine squared is 1, and here I get 1 over sine squared theta. Now if I use the definitions, I know that tangent is sine over cosine. So here, if I have cosine over sine, it must mean 1 over tangent squared. That's 1, and I know that 1 over sine is cosecant, as I've defined just now. So this is cosecant squared theta. And again, using the definition of cotangent, remember cotangent is 1 over tangent. So 1 over tangent squared is the same as cotangent squared. And this is the third identity that completes the proof. We'll stop here.